Hello, everybody. It's me again, Richard Ray. Today we're going to be talking about forms of energy. Okay, and before we start that, let's first look at this little table that I made, which basically distinguishes two types of energy. There are two types of energy. Okay, so we have potential energy and kinetic energy, and this is all related to physics, but we're not going to get too in depth with the explanations. But just so you know, potential energy, okay, it's basically energy. But before that, before we define what potential energy is, let's define what energy is in general. Okay, so energy is anything. Okay, it is anything, and this is the formal definition of energy. It is anything that can produce work, produce heat, or anything that can create a change in the form of any matter. So, let me elaborate on what I meant by work. Work in physics basically just means that it is the ability to sort of have an effect on anything, provided that an object has a motion and is applying is applying a force on a certain matter at a distance. So that is what work means. Okay, so potential energy is basically anything that is basically stored in anything that you can see. Like for example, okay, a chair. A chair has potential energy. If you push a chair, okay, let's say you have a chair and you're at the top of a mountain or a hill. You're at the top of a hill and the hill is very steep. And if you took the chair from the top and then you drop the chair from the steep hill, that potential energy, okay, that energy, the potential energy that is stored in chair is converted into kinetic energy. And what is kinetic energy? Okay, so let's also define what kinetic energy is. Kinetic energy is basically just the energy. Okay, it's basically just an energy that relates anything to movement. Okay, but we're going to elaborate on that later. But first, let's talk about the types of energy under potential energy. So the first is chemical energy. If we're looking at the examples right here, the examples of chemical energy would be batteries. Okay, and how does chemical energy relate to batteries? Okay, if you look at it, okay, if you really try to dissect what a battery is, it's basically just made out of chemicals that react with each other in order to create sort of electrical impulses that could then signal to sort of store power for example, like electronic devices. And gasoline also is a form of chemical energy. Why? Because if you use gasoline in a car, okay, if you use gasoline for a car, you're technically using gasoline as fuel. Then, consequentially, that car can move. You could drive that car. The concept behind it is that these chemicals, they would then be converted into kinetic energy. which is you driving your car. The only reason why you got that kinetic energy is because of this chemical energy, gasoline. Okay? There's also coal. Coal is also an example of chemical energy because coal, as you may know, is used for combustion, and when coal undergoes combustion, it can fuel mechanical devices, such as factories, such as the ones in the factories, and that's basically what coal does, right? So there's also food. Okay, food is also a form of chemical energy. Why? Because if you digest food, consequentially you will gain the nutrients, and the nutrients help you to survive. And if you survive, then you can move. Then there is also kinetic energy, right? From you moving, from you being able to move because of the food. That is chemical energy. That is what chemical energy is. Okay. So the next type of potential energy is the mechanical energy. If you look at this illustration right here, it says that mechanical energy arises due to an object's position and motion and results in work. If you listen to what I mentioned earlier about work in physics, it basically is the result of anything that applies a force, provided that there is a distance between the two matter. And that's basically what work is. So if you see this drawing right here, the position of the hammer, okay, right before it hits the nail, the position of the hammer is already above the nail. And then there is a motion. When you strike the hammer, okay, there is a sort of motion before it strikes, right? Then, and only then, when it does hit the nail, work happens. That's basically the gist of mechanical energy. Okay? Mechanical energy happens when there is motion, okay, in an object, and that preceding motion results in a result. It basically just does something, okay? Just does something to change the state of any sort of matter, okay? That's what mechanical energy is. So let's go to the next type of potential energy, okay? So if you watched my video on strong and weak nuclear forces, like all of the forces, governing forces of the universe, you would remember that I talked about nuclear energy. There are two types of nuclear energy. There is strong and weak. The strong nuclear energy, okay, if we're going to look at quantum mechanics, okay, if you have an atom and you look at the nucleus of the atom, the strong nuclear energy basically just does what it basically just does is that it stabilizes the nucleus of the atom. And how does it do that? Okay, well, it just does. Like, it stabilizes the nucleus of the atom. Why? Because there is protons and neutrons. Okay, inside the nucleus, okay, you have protons just moving around, just getting tangled around inside the nucleus, right? The protons, if you have an idea on what charges do, okay, there are like charges and there are unlike charges. Like charges, they repel each other. So when you have two protons or three or more than that, then those protons are basically just repelling each other because they all have positive charges. And when those protons basically just repel each other, okay, they're obviously just getting farther and farther away from each other. And they're all contained in this little container this little box. Okay, this little box called the nucleus. And there gets a point where those you kind of think about it, right? If those two are repelling each other, and the box that they're in is not all that big, then obviously they're going to get to the sides of that box because they're repelling each other. They're trying to get as far away from each other. There is some level of distance between the two. Okay, and there is still a force between them that is trying to repel the other. And when that force, just stays there, then they're just going to stay at the sides of the box, or in this case, the sides of the nucleus. So then you would think, how could that box withstand all of that energy? How could that box withstand the forces of the two protons? Well, that's where strong nuclear energy comes in. It basically stabilizes the nucleus. So as, like, let's say, so as the nucleus wouldn't get torn apart because of the force of protons that are repelling each other, that are constantly repelling each other. So that is what a strong nuclear energy is. And there is also a weak nuclear force, which basically just does radioactive decay. What is radioactive decay? Radioactive decay is basically just the changing of the protons to neutrons and neutrons to protons through certain reactions that trigger them. So that's basically what nuclear energy is. Okay? There are also types of sort of results from this nuclear energy. There is what we call nuclear fission, nuclear fusion. What is nuclear fission? Well, let me just explain. Okay, nuclear fission is basically just the opposite of nuclear fusion. If you say you have an atom, let's say you have let's say you have a uranium atom. That uranium atom, if you were to slice it into, no. That uranium atom, let's say you have two components of that uranium atom, and those two components basically just mix together through some method or whatever. Okay, that is what nuclear fission is. Two small atoms that basically create another bigger atom. That is what nuclear fission is. And nuclear fusion. Oh, no. That's actually nuclear fusion. Sorry for the confusion. That is actually nuclear fusion. Nuclear fission is where is a larger atom. Basically, this splits into two smaller atoms or more. So that's what nuclear fission is. And that's basically the gist of nuclear energy. So let's go to another type of potential energy, which is the last type of potential energy, which is gravitational potential energy. So that's a big word, right? So let's dissect it all together. You can see from the illustration right here, it says gravitational potential energy is stored energy due to the relative position of an object in the gravitational field. And it says here, Earth has gravitational potential energy as it revolves around the sun. The Earth orbiting the sun. Okay? That is gravitational potential energy. Okay? It has gravitational potential energy. It has the energy to do so, to be able to orbit the sun. Let's have an example. Let's say, okay, let me just hold on. Let's have an example here. I forgot that you could draw on Canva, but let's have an example in gravitational energy. Let's say you're here. Space is too small. Hold on. So, oh man, let me space this. Let, let's say you're here, and there's a building right here. Let's say there's a building right here, and there's two people. Okay, there's two people, and this one's on the top of the building, and this one, the top of the building, has a bag. That bag has gravitational potential energy. Why? Because if you could imagine this, okay, he's standing on top of a building. This bag is basically just dangling there with no support, but the hands of the person who's holding it. It has gravitational potential energy. Why? Because if you look at it, if you think about it really, the bag can just fall any moment. It could just fall down any moment. If the person wasn't holding the bag, that gravitational potential energy will then be converted to kinetic energy, which is motion. It basically just gets pulled down as a result. If there wasn't a force actively holding it up from falling down. And the same case applies in the inverse. Let's say the person that is on the ground has a bag as well, and then he aims to throw it. That is gravitational potential energy. Okay, why? Because if you throw it, okay, before he even threw it, there's already gravitational energy that is happening. Okay, because that bag is still getting pulled downwards. That bag is still getting pulled downwards. And if you were to throw it, if you were to throw that bag will still get pulled downwards. Okay? But there is a catch. There is a catch. The gravitational potential energy, let's just denote it as GPE. GPE is equal to mass times G H, mgh. Let's just denote it as that, you know. And what it basically just does is that whenever all of this are directly proportional to each other, these three variables that I stated here are all directly proportional to each other. Why? How? How is it? Okay. But first, let's define the variables. M stands for mass, G stands for gravity, and H stands for height. If you have an object and you were to put it upwards, so let's say you were at a satellite or a spaceship and you were at the atmosphere of the Earth, and you held the bag, you held the bag just there, okay? You somehow find a way to get out of the satellite or the spaceship, and you held the bag the same way that you were that is in this example with a person on top of the building. Let's say you held two bags. Let's say this is the Earth, right? And I'm just using this example from the organic chemistry tutor. Let's say you have two bags. And one bag is higher than the other. Okay? One bag is higher than the other. You held two bags atop the world. No, just above the world. And then you held two bags. One bag is higher than the other. The other bag is lower than the other bag. Which do you think is going to fall faster? The one, the bag that is held lower, or the bag that is held higher? Which do you think will fall faster? If you answered the bag held higher, you're correct. Because if you think about it, okay, GPE equals MHG, MGH. All of these are directly proportional to each other. If one is higher, then the others are higher as well. So if you have an object that is higher, okay, that is held higher, the gravitational energy is higher as well. So it falls down quicker. You get what I'm saying? And this thing applies as well with mass. So if you had an anvil, okay, suppose you had an anvil and you had a feather, and we're negating air resistance altogether. Okay, let's hypothetically speaking, if you had a feather, you had an anvil, which do you think will fall faster? The anvil or the feather? The anvil, obviously, because the anvil has higher mass. Okay, it's higher mass. Therefore, its gravitational energy is higher. See, that is what gravitational potential energy is. So now, let's talk about kinetic energy. Let me just erase this. So kinetic energy, okay? What is kinetic energy? As I've explained earlier, kinetic energy is basically just the energy that moves, that it just moves. So let's have an example there. Let's talk about the first type of kinetic energy, radiant energy. What is radiant energy? If you look at the illustration right here, there is some arrows. There's some squiggly arrows emanating from the sun to the plant. Whenever a plant goes through photosynthesis, it is actively absorbing radiant energy. How? Because the sun, okay, if you think about it, if you really think about it, the sun is emanating UV rays. Radiant rays, yeah. So, UV rays, this is basically energy as well. Okay? UV rays are energy. And with that energy, it's basically moving. The UV rays are moving, right? It's moving. That is radiant energy. Anything, any wavelength that you can possibly think of is a part of radiant energy. If you think about the electromagnetic spectrum, there are types of waves. There are UV rays, there are gamma rays, there are X-rays, there are also, what do you call that? Microwaves, not the microwave, okay? So microwaves, there are a lot of waves. All of those are radiant energy. When you go to the hospital and you get an X-ray, you're actively being exposed to radiant energy, because X-rays, they're moving. They're technically moving through your body. Correct me if I'm wrong. Those little waves, just to get a picture of what's inside you. That's what radiant energy is. So the next is thermal energy. Thermal energy. When you think about thermal, when you hear the word thermal, what do you think about? Temperature, right? You would be correct. Temperature has something to do with thermal energy. Thermal energy is basically just heat. Okay? If you look at the illustration right here, if you look at the example of thermal energy right here, you have a pot that is below a source of heat. Okay? And inside that pot, the water is basically boiling through convection. The heat that is radiating, okay? So heat can also be radiant. So the heat radiating underneath the pot is actively causing a reaction inside the pot, inside the boil, and it causes it to boil. Okay? So that is what thermal energy is. It's basically just heat. It's basically anything that relates to heat. Just like this, okay? The heat source has thermal energy. And consequentially, okay, that thermal energy can be passed down through this pot. That's why it gets heated. So that's what thermal energy is. So the next type of energy is motion energy. And this is what we've been talking about earlier so much. Motion energy. It's just the energy of motion. If you think about inertia, let's say you're in a moving car, and when you suddenly stop that car, okay, while you suddenly stop that car, you basically like recoil. Okay, you basically just recoil before you actually stop. That is that singular microscopic moment of you not stopping at all, okay, of you not stopping after the car stopped, is leftover motion energy. That is motion energy. The singular moment of you not stopping during inertia, when you're driving a car, is leftover motion energy. And if you look at this, okay, that example that I gave right now can be better illustrated by this example right here in the screen. If you can see right here, there is a man. He's holding a hammer. He holds the hammer to the back of his head, and when he goes to strike it, his head goes to the hammer instead. Like he basically just hits himself with a hammer. That's basically what motion energy is. Before that hammer hit the wood here, before it hit the nail here, there was motion energy. Okay? There was also motion energy with the person who got himself hit on the head with a hammer. Why? Because as he was actually like putting the hammer to his side, to the back of his head, he was actively sort of generating motion. He was actively generating motion energy. That motion energy, okay, because the hammer, okay, you can safely say that the hammer is a little bit heavy in this scenario, because the person, okay, leaned over with it, and there was motion energy with the person as well, because the hammer was so strong, okay, that it basically generated motion energy for a person to fall towards the hammer as well. So that is what motion energy is. So the next type of kinetic energy is sound energy. Anything that you hear right now, that is technically energy. The sound of an alarm, the sound of my voice, that is sound energy. The music that you hear, the music that you play every day, that is sound energy. Okay? Everything is sound energy. Anything that you hear is sound energy. That's basically it. You don't need to elaborate more on that. So the next, and the last type of kinetic energy that we're going to be discussing today is electrical energy. Okay? Electrical energy happens because the electrons, particles with a negative charge, they're moving and interacting with each other to create electricity. That is what electrical energy is. Okay? You probably don't need more in-depth explanation with electrical energy, because you're already experiencing right now. If you're watching this video, you're experiencing electrical energy because your laptop or your phone had to be charged. Okay, it had to be charged prior to watching this video, or any sort of device that you're using. And how did it get charged? Electrical energy. So that's basically it, guys. Thank you guys for watching. If you learned anything from this video, if you liked it, please give me a thumbs up, subscribe. If you didn't like the video, give me your honest feedback in the comment section. I'll be sure to read it. I'll see you guys in another video. Peace.